This is Mrs. Zappia with an answer key for the practice test for Grade 8, Module 4, Lessons 10 through 14, Topic B. Question 1. Find 4 solutions and graph the linear equation. To find 4 solutions, you will choose values for either x or y, and then solve for the other variable. I'm going to choose values for x. I'm going to choose a positive 2, 0, and negative 2. Then I'm also going to choose one value for y, which is 0, and that's going to tell me what the x and the y intercept are going to be. When you let x equal 0, you'll find the y-intercept. When you let y equal 0, you'll find the x-intercept. So I'm going to rewrite my equation, and I'm going to just leave a space for the value that I'm substituting. And I'm going to do that for each problem. For this problem, I'm going to be substituting y, so I'm going to leave x in the equation. Next, I'm going to substitute all of my values for x. So I'm going to be taking x out and putting the value of x in. And for this third line, I'm going to be taking the value of y out, and I'm going to be substituting the 0 in. Now go back and then show every step to solve for the unknown variable. 2 times 2 is 4. 4 minus y is 9. Subtract 4 from both sides of the equation. Negative y is equal to 5. Multiply both sides of that equation by negative 1. A negative times a negative is a positive, leaving you with y, and y is equal to negative 5. For the next one, 2 times 0 is 0. 0 minus y is negative, or is 9. So we have negative y equals 9. Multiply both sides by negative 1. Negative times negative is positive, so we have y equals negative 9. 2x minus 0 equals 9. 2x equals 9. Divide both sides by 2, or multiply by the reciprocal of 2, which is 1/2. 2 divided by 2 is 1. 1 times x is x. 9 divided by 2 is 4.5, or 4.5. Negative 2 times 2 is negative 4. Negative 4 minus y is 9. Add 4 to both sides of the equation. Negative y is equal to 13. Multiply both sides of the equation by negative 1. Negative times negative is positive, and y is equal to negative 13. Now I've got my ordered pairs. When you write ordered pairs, make sure and put parentheses around them to show that they are not just random numbers, but are rather a solution, an ordered pair. 4.5 and 0, and negative 2 and negative 13. Next, on my graph, I'm going to go by ones, so I don't need to number my graph. If I'm going by anything other than ones, you will want to number your graph. For the ordered pair 2, negative 5, I go over 2 and up 5 and put my dot. Then 0, 9. For the first 0, you do not go left or right, you stay at x equals 0, and then you go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice when 0 is one of the ordered pair that will be on an axis, and it will show an intercept where the line intercepts the axis. Okay, for positive 4.5, 1, 2, 3, 4, 4.5 is right here, 4.5, 0. And then lastly, negative 2, negative 13. Negative 2, negative 9, 10, 11, 12, 13. Now, what I'm noticing is that these do not appear to be in a straight line. So what I want to do is check to see, did I make an error in one of my arithmetic problems? I know that this is a linear equation because the coefficients of, or rather, the exponents of x and y are not other than 0 or 1. So I would expect this to be in a straight line. So I believe that this point may be wrong. So I'm going to go back and double check first to make sure that I graphed it correctly. If I graphed it correctly, then there may have made an arithmetic mistake. So positive 2, negative 5. Positive 2, negative 5. So it should not be up here in the positive quadrant. It should be down here in the negative quadrant. So positive 2 and then negative 5. 1, 2, 3, 4, 5. Now I have a linear equation and dots that appear to be in a straight line. So now I am convinced that this was a mistake. So I'm going to erase that. So again, if you are expecting a line for your solutions and you do not get one, then you want to double check. You may have graphed it wrong, as I did, or you may have made an arithmetic mistake. Graph the linear equation ax plus by equals c, where a equals 1, b equals 0, and c equals 4. So these are going to be our coefficients for x and y. We're going to replace a with 1, so that's going to be 1x. We're going to replace b with 0, 0y. And we're going to replace c with 4. 1 times x is x. So this equation is x, 0 times y is 0, and x plus 0 is x. So x is equal to 4. So both of these equations are going to give me the same line. I'm going to use 1x plus 0y equals 4 to help me find ordered pairs, because an ordered pair has an x and a y. We know that x equals 4, so for this problem you want to choose your y values. I'm going to use 7, 0, 2, and negative 4. It's not a bad idea to use a positive, negative, and 0. So now I'm going to go and put a place to substitute that value for each line. Paying attention to detail. And this will be 1x plus 0 times a value, and that's going to equal 4. 1x plus 0 times a value is equal to 4, and 1x plus 0 times a value is equal to 4. Okay, it's equal to 4 every time. Now I'm going to substitute my y value. My y value is going to go in this spot. And my y values are 7, 0, 2, and negative 4. So we have 1x plus 0 times 7 is 0 equals 4. 1x plus 0 equals 4. 1x plus 0 equals 4, and 1x plus 0 equals 4. So we have 1x, which is x. X plus 0 is x equals 4. 1x is equal to x. X plus 0 is x, and that's going to be equal to 4. 1 times x is x. X plus 0 equals x, and x is equal to 4. 1 times x is x. X plus 0 equals x equals 4. So I have x equals 4 every time. We knew to expect that. So we have 4, 4, 4, and 4. So our ordered pairs are 4, 7, 4, 0, 4, 2, and 4, negative 4. Graphing our ordered pairs. 4, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 4, 0. 1, 2, 3, 4, 0. 4, 2. 1, 2, 3, 4, 1, 2. And 4, negative 4. 1, 2, 3, 4. 1, 2, 3, 4, negative. Notice that they are in a straight line. I would expect a linear equation because the exponents for x and y are not other than 0 or 1. Notice when you have an x equals that your line will be perpendicular to the x-axis. This is your x-axis, and your line for an x equals problem will be perpendicular to the x-axis. Graph the equation y equals -4. For y equals -4, it's a good idea to know what kind of a line to expect. It will be linear because there is not an exponent other than 0 or 1. It will be perpendicular to y. So this is your y-axis. Perpendicular to y will look like this. So this is the kind of a solution that we will expect. Since we know that y equals -4, we will want to choose our x values. It's a good idea to choose a positive, 0, and a negative. When you write your equation, it's a good idea to include the x and y variable. Since an ordered pair has an x and y value, that will help you figure out what to use for the other value. So we know that y equals 4. Actually, -4. And you think, well, what do I use for x? Well, we want to use 0x because 0 times x is 0. And 0 plus y is how you get y here. So this is our equation, and we're going to be substituting the x value. So I'm going to replace all of these spots with parentheses. And I have 0 plus y plus y plus y equals -4 equals -4 equals -4. Then I'm going to substitute my value, 2 for x, 0 for x, and -2 for x. Then show every steps to avoid mistakes. 0 times 2 is 0. 0 plus y equals -4. 0 plus y is y. Y equals -4. 0 times 0 is 0. 0 plus y is y. And y is equal to -4. 0 times -2 is 0. 0 plus y is y. And y is equal to -4. So our y value is equal to -4, which we knew because it says right here our equation y equals -4. This is just a way to help you find ordered pairs. Once you've got your ordered pairs, graph them. So we have +2, -4. +2, -4. 0, -4. And -2, -4. So this will be the equation of a line, y equals -4. Notice that it matches what we expected. It is perpendicular to the y-axis. In the next question, graph the linear equation x equals -4. You'll want to identify what your line should look like. X equals -4 is going to give us a line that will be perpendicular to the x-axis. Your x-axis runs this way, so the line we will expect will run this way. Again, we want an ordered pair x and y. We already know that x is going to equal -4. So let's choose some y values to help us find some ordered pairs. It's a good idea to use a positive, 0, and a negative. When you write your equation here, it's a good idea to have an x and a y variable. We know that x is equal to -4. There is no y, so we'll use 0y, and that's going to equal -4. Now for this we want to substitute all of the y values. So I'm going to put a space for all of the y values that we have chosen and just bring down the rest of the equation. Then I'm going to substitute these y values. And do not skip any steps. That will help you avoid mistakes. 0 times 2 is 0. X plus 0 is x. Bring down the negative 4. 0 and x plus 0 is x. Bring down the negative 4. I was going to say negative 2. 0. X plus 0 is x. Bring down the negative 4. So x is equal to negative 4 every time. We knew that. Now we have ordered pairs. Negative 4, 2, negative 4, 0, and negative 4, negative 2. You'll see that no matter what you use for y, your x is always going to be negative 4. So you could just pick any number you want. You could do another negative if you wanted to. You could do another positive if you wanted to. All right, so we go over to negative 4. 1, 2, 3, 4, and then up to 2. Our next ordered pair, negative 4, 0. 1, 2, 3, 4, 0. For negative 4, negative 2, 1, 2, 3, 4, and negative 2. Negative 4, negative 5, negative 4, positive 5. And notice the equation of a line is as we expected. Here's our x-axis, and when you have an x equal, it will be perpendicular to the x-axis. Next, is negative 5, negative 6 a solution to the equation? What you'll want to do here is mathematically prove it. So you're going to substitute the value for x and the value for y. Remember that the first of the ordered pair is the x. So we have negative 6. Substitute negative 5 for the x value. Substitute negative 6 for the y value. And you want to see if it equals 30. If it equals 30, then negative 5, negative 6 is a solution. So this is going to be a positive 30, and this is going to be a negative 30. Continuing on this side of the equation till it's simplified. These are opposites. Opposite equals 0. 0 does not equal 30, so this is not a solution. Next, is 4, 0 a solution? So we're going to substitute the x value and the y value. So the x value is 4 plus 2 times the y value, which is 0, equals 5. Simplify both sides of the equation. On the left, we have 4 plus 0, and on the right, we have 5. These are not equal, so this is not a solution. So when it says to explain and prove it, you want to substitute the x and the y value. Simplify both sides of the equation and see if they are equal. A copy machine makes copies at a constant rate. The machine can make 120 copies in 2.5 minutes. Write an equation to represent the number of copies, p, that can be made over any time interval. Hint, copies per minute. So we're going to have copies over minutes. We have 120 copies in 2.5 minutes. You can leave this as a complex fraction if you would like to, but since you're going to be using it in an equation, it's better to do the division and change it to a decimal. So we have 120 divided by 1.5, and that equals 48. And so we have 48 copies per minute. To write the linear equation, we know that y equals kx, where k is the constant rate. So we have y equals 48x, and y is our p-value, So we have P equals 48, and X is our copies, C. So this is our equation, or our linear equation. Next, complete the table. So we're going to find out for 0 minutes how many copies are made, for 0.25 minutes how many copies are made, etc. So we're going to be substituting our time in minutes. And I noticed that I have made a mistake with using C for copies and P for paper. All right, so again, we're supposed to be using P for copies, so I'm going to change that. P for copies and T for minutes, and this will be our Y value will be P, and our X value will be T. So the number of paper copies is equal to 48 copies per minute times the number of minutes the copy machine is being used. Next, complete the table. We are going to find out how many copies are made when there are 0 minutes used, 0.25 minutes, half a minute, 3/4 of a minute, and 1 minute. So we're going to be substituting the T value. And we're going to be multiplying that times 48 copies per minute. And that is going to give us P, the number of copies that are being made. Next, substitute in the values. 0, 0.25, 0.5, 0.75, and 1. Then do the math. 48 times 0 is 0, so P is equal to 0. 48 times 0.25 is 12, so P is equal to 12. 48 times 0.5 is 24, P equals 24. 0.75 times 48 is 36, P equals 36, and 1 times 48 is 48, so P equals 48. Next, graph the data on the coordinate plane. To graph the data, you need an X and a Y value, or in this case, a P and T value. So the time in minutes is our X-axis, and then we have copies here. And our ordered pairs are 0, 0, 0.25, 12, 0.5, 24, 0.75, 36, and 1, 48. The numbers on the graph were vague, so I'm going to take a minute and write those in. Graphing my ordered pairs. The first ordered pair is 0, 0. So when you have 0 minutes, you have 0 copies. The next one is 0.25, which is halfway between 0.2 and 0.3, 0.20 and 0.30. So here is 0.25, and I need to go up to 12. Then 0.5, which is a half, and up to 24. Notice that I'm getting a straight line, which I expected because this is a linear equation. The variables do not have exponents other than 0 or 1. Then we have 0.75 and 36. 0.75 is going to be halfway between 0.7 and 0.8. Notice that I have a straight line. This last point will not fit on my graph. However, if I extended a straight line, I could see where it would go. Next, the copy machine runs for 90 seconds, then jams. How many copies are made before the jam occurred? Explain. So you want to be careful about the 90 seconds. These copies are in terms of minutes, and if we graph 90 That would be 90 minutes. We want 90 seconds. So 90 seconds, convert that to minutes. 90 divided by 60 is equal to 1.5. So this is 1.5 minutes. 1.5 minutes. We know the number of copies in 1 minute is equal to 48 copies. And we know that a half a minute is equal to 24 copies. So if we add that up, we get 1.5 minutes, and if we add the number of copies, we get 72. So 72 copies will be made in 1.5 minutes. Tina bikes at a constant speed from her house to Dairy Queen, 20 miles away. It takes her 2.5 hours. What fraction represents her constant speed? C. So we're talking about time and distance. And when you're talking about speed, we usually generally talk about it in miles per hour. And this distance is given in miles and the time is given in hours. So we will use miles per hour. Write that as a fraction, miles per hour. We know that it's 20 miles, so we replace the miles with 20. We know that the hours is 2.5. 2.5. So this is her constant speed. The next weekend, she bikes at the same constant speed. It takes her 1.75 hours. Write the fraction that represents the constant speed, c, if she travels a distance of y. So again, we're going to use miles per hour. Write that as a fraction, miles per hour. Now substitute the values. The hours is 1.75, and the number of miles is unknown, but we are told to use a variable of y. And so this is the fraction that represents the same constant speed. Write the fractions from part A and B as a proportion and solve to find out how many miles it is from Pete's Park to Tina's house. Now, the reason that we can write these two fractions as a proportion is because Tina is traveling at the same constant speed. So we know that these two rates will be equal to each other. So a proportion is two fractions that are equivalent. We have 20 over 2.5. At the same rate, she traveled y miles in 1.75 hours. Now solve to find out how many miles Pete's Park is. So my answer is going to be in miles. To write your equation, use the cross product. We have 2.5y is equal to 20 times 1.75. Bring down 2.5y, simplify on the right, and that gives us 35. Then divide both sides by the coefficient 2.5, and y is equal to 14. 14 what? 14 miles. Tina's friend Jeff can bike at a constant speed from his house to Tina's, 5 miles away. It takes Jeff 30 minutes. Who has the faster rate, Tina or Jeff? So you want to write their rates and then compare them. We have Tina's rate and Jeff's rate. We know that Tina's rate is 20 miles in 2.5 hours. And again, this is miles over hours. And we know that Jeff's rate is y over 1.75. Rather, that's incorrect. Jeff's rate is given right here, 30 minutes and 5 miles. So miles will be 5 and 30 minutes. Now I'm not going to use 30 right here. That would be incorrect because the minutes and the hours, you have to use the same unit of measure on both of those fractions. Since Tina's rate is given in hours, then Jeff's rate needs to be given in hours as well. And 30 minutes is equivalent to a half an hour, or 0.5. So we'll use 5 over 0.5. Now we want to compare these. Tina's rate. They have different denominators, so they're difficult to compare as they are. But we can find out how far each person travels in 1 hour and then compare those amounts. So 20 divided by 2.5 will be the unit rate. And that gives us 8 miles per 1 hour. And then here, the division, 5 divided by 0.5, gives us the unit rate. And that gives us 10. That means 10 miles per 1 hour. Since Jeff can travel farther, Jeff is faster. Jeff is faster because he travels farther in the same amount of time. So when you're comparing their speeds and you're talking about miles per hour, the person that is faster is the higher number because you go farther in the same amount of time, 1 hour.